Potassium ferrioxalate. Aim. Preparation of potassium ferrioxalate. Chemical and apparatus required. Apparatus: 2 beaker, 2 test tubes, 1 china disc, 1 glass rod, 1 filter paper and 1 funnel. Chemical substance: oxalic acid, ferric chloride, potassium hydroxide. Theory: potassium ferrioxalate is a chemical compound with the formula K3Fe trioxalate. It often occurs as the trihydrate. Both are crystalline compounds, lime green in color, also known as potassium trioxalate ferrate or potassium trisoxalato ferrate third. The compound is a salt consisting of ferrioxalate ion and potassium cation. The anion is a transition metal complex consists of an iron atom in the +3 oxidation state and tribidentate oxalate ion acting as ligand. Potassium acts as a counterion balancing the -3 charge of the complex. In solution, the salt dissociates to give the ferrioxalate ion, which appear fluorescent green in color. The ferrioxalate ion is quite stable in the dark but is decomposed by light and higher energy electromagnetic radiation. This feature is exploited for chemical actinometry, the measure of light flux, and for the preparation of blueprints. IUPAC name: potassium iron oxalate. This is the chemical formula of potassium iron oxalate. Preparation of potassium ferrioxalate. First, ferrichloride react with oxalic acid to form iron compound and HCl. Further, this iron compound react with oxalic acid to form a complex, and this complex further react with KOH to form potassium ferrioxalate. Chemical properties: photoreduction. The ferrioxalate ion is sensitive to light and to higher energy electromagnetic radiation, including X-ray and gamma rays. Absorption of photon causes the decomposition of one oxalate to carbon dioxide and reduction of the iron third atom to iron second. Thermal decomposition. The trihydrate loses the 3 water molecule at the same time when heated at 113 degrees centigrade, 296 degrees Celsius. The anhydrous salt decomposes into the iron second complex potassium ferroxalate, potassium oxalate and carbon dioxide. This is the representation of above reaction. The light catalyzed redox reaction once formed the basis of some photographic process. However, due to their insensitivity and the ready availability of digital photography, these processes have become obsolete and light but forgotten. Uses of potassium ferrioxalate: photometry and axonometry. The discovery of efficient photolysis of the ferrioxalate ion was a landmark for chemical photochemistry and actinometry. The potassium salt was found to be over 1000 times more sensitive than uranyl oxalate, thus compound previously used for these purposes. Procedure: take 1.6 gram of ferric chloride and dissolve in 2 ml of water. Add 2.3 gram of potassium hydroxide slowly. Add a solution of oxalic acid in hot solution 8 ml and potassium hydroxide 0.7 gram. Mixing the above reaction mixture properly and stand overnight. A green solid crystals of potassium ferrioxalate forms. The filter the above mixture, wash with cold water, alcohol and dry the formed ionic compound. Let's see the video for the preparation of potassium ferrioxalate. Yield was 2.4 gram.